In the last lesson, I split lesson 9.5 in half and talked only about kites. So in this video, I'm going to talk only about trapezoids. So a trapezoid is a quadrilateral with, please correct your textbook. It should say exactly one pair of parallel sides. There are some old antiquated texts that might use the at least definition, but they are very, very few and far between. The overwhelmingly accepted definition for a trapezoid is that it has exactly one pair of parallel sides. So a little bit of vocabulary with the trapezoid. The parallel sides are what we call the bases of the trapezoid. So in this figure here, these are the bases. And then the non-parallel sides are called the legs. In an isosceles trapezoid, the legs are congruent. So a couple of properties of isosceles trapezoids. If we have an isosceles trapezoid, then each pair of base angles are congruent. So that's some vocabulary that is mentioned up here. These would be a pair of base angles. And these would also be a pair of base angles. This is also a condition for a trapezoid to be isosceles. If I know that the trapezoid has a pair of congruent base angles, then we would say that the trapezoid is isosceles. And another property of isosceles trapezoids is that the diagonals are congruent. Notice the wording here, this if and only if, means that statement goes both ways. If I know the trapezoid is isosceles, then I know that the diagonals are congruent. And if I know that the diagonals of a trapezoid are congruent, then I know that the trapezoid is isosceles. That's what I mean by going both ways. In this proof, we are given that ABCD is an isosceles trapezoid. And then the rest of the given is just kind of clarifying that definition, the fact that BC must therefore be parallel to AD and AB is congruent to CD. So I'm given that BC is parallel to AD, and then in addition to that, they said draw CE parallel to BA intersecting AD at E. Okay, so I've just got, I drew a parallel line because I'm allowed to do that because of the parallel postulate. Remember that the parallel postulate says if I have a given line, in this instance it's AB, and I have a point, in this case it's C, there's exactly one line passing through that point that's parallel to my given line. So we drew it. Okay? And then angle A is going to be congruent to something because of the corresponding angles theorem. So angle A is corresponding to angle CED. They are corresponding angles theorem, or they are corresponding angles. At this point, I want to apologize for an error in the textbook. This arrow is wrong because in my next step, I'm going to say that ABCE is a parallelogram, but it has nothing to do with this statement. The arrows should be coming from here and here because the definition of parallelogram says I have two pairs of opposite parallel sides, here and here. So I apologize for that error. Now, because it's a parallelogram, I know that AB is congruent to EC. I also happened to have been given that AB was congruent to DC. So if AB is congruent to EC and AB is congruent to DC, that means DC is congruent to EC. That's over here in this triangle. So because of the isosceles triangle theorem, I'm allowed to say that angle CED is congruent to angle D. But hold on a minute. A while back, I said that angle A was congruent to CED. So this statement here and this statement, their arrows are going in the right place, because now I'm allowed to say that angle A is congruent to angle D because of the transitive property of congruence. Here we're proving that if I have a trapezoid where the base angles are congruent, I can show that it is an isosceles trapezoid. So I'm basically proving the exact opposite, or not opposite, but in the opposite direction of what I just finished proving. Okay, so it is given that BC is parallel to AD. By the parallel postulate. So hopefully you're kind of starting to see that the proofs will resemble each other. CE can be drawn parallel to AB so that CE intersects AD at the point E. By the corresponding angles theorem, because I know that BC is parallel to AD, angle A will be congruent to angle CED. It was given to me that angle A was congruent to angle D. So by substitution, I know that angle CED is congruent to angle D. And in this proof, I'm using the converse of the isosceles triangle theorem because I have the angles being congruent. I'm using them to say that the sides are congruent. So I'm saying that CE is congruent to CD. So let me backtrack a little. By definition, ABCE is a parallelogram. And in a parallelogram, opposite sides are congruent. So that means that AB is congruent to CE. So since back here, I said that CE was congruent to CD, and now I just said that AB was congruent to CE, I take those two statements and smush them together, and I end up with AB being congruent to CD. So by definition, ABCD is an isosceles trapezoid. So let's use properties of isosceles trapezoids, or any trapezoid. So in this figure, I happen to have an isosceles trapezoid, and I'm given a bunch of measurements that AC is 13.2 and BE is 8.4. Asked for the length of DE. So I know that AC equals BD, and that means that BD equals 13.2. Using the segment addition postulate, I know that BE plus DE equals BD. And when I substitute into that equation everything that I know, I have that 8.4 plus DE equals 13.2. And when I solve, I get that DE is 4.8. In this example, I am finding the value of x so that this trapezoid would be isosceles. So the values of x are thrown into a pair of base angles. I know that base angles are supposed to be congruent, so E and F would have to be congruent. And that means that the measure of angle E would have to equal the measure of angle F. And so I'm going to substitute 3x squared minus 4 for the measure of angle E and 2x squared plus 21 for the measure of angle F. So now I have the equation 3x squared minus 4 equals 2x squared plus 21. I'm going to subtract 4, oh no, sorry. I'm going to subtract 2x squared from both sides. And add 4 to both sides to get that x squared equals 25. So that means x equals 5 or negative 5. A few more examples. In this isosceles trapezoid, I'm using the same side interior angles postulate to find the measure of angle R. So this is the angle that I'm trying to find. Because this is an isosceles trapezoid, I know that angle R will be congruent to angle S. Angle S and angle P are same side interior angles with respect to two parallel lines. So I know that the measure of angle S plus the measure of angle P has to add up to 180. So I'm going to substitute angle R in for angle S, 77 in for angle P, and I'll have that the measure of angle R plus 77 has to equal 180. So measure of angle R must equal 103. In number 9, I have the length of JL and the length of KM, so those are the lengths of the two diagonals, and they're asking me to determine the value of Y so that this trapezoid would be isosceles. In order for this trapezoid to be isosceles, my diagonals have to be congruent. So I set them equal to each other. I get 3y plus 6 equal to 22 minus y. 4y equals 16 and y is 4, and they were only asking me for the value of y, so I am in fact done. We saw in module 8, I think, mid-segment of a triangle. Mid-segment of a trapezoid is kind of the same idea. It is a segment connecting the midpoints of the legs of a triangle. And so a mid-segment has some interesting properties, just like it did in a triangle. If you'll recall, in a triangle, the mid-segment was half the length of the third side, which it was also parallel to. Now, in here, I've got more than just 3 sides. So the property is a little bit more involved as far as this is concerned. But if you think of it in terms of the mid-segment, the length of the mid-segment is the average of the bases. That might help. So in this trapezoid, I'm asked to find the length of xy. Xy is a mid-segment. So we see that they're using the second part of the mid-segment theorem and saying that xy has to equal half of the sum of EH and FG. They substituted their values in, and then they just typed stuff into their calculator. We're going to do the exact same thing in part B. So PQ is going to equal half the length of KL plus JM. I'm going to substitute in X for PQ. Oh no, this time I know the length of PQ. Oh. So I'm going to substitute in 9.8 for PQ and 8.3 for KL. So 9.8 equals 1/2 times 8.3 plus JM. If I multiply both sides by 2 to get rid of that fraction, I have 19.6 equals 8.3 plus JM. And when I subtract the 8.3 from both sides, I get 11.3. Last example, I am told that the length of PQ is twice the length of RS. So if PQ is twice as long as RS, then I know that RS is 8.4. And if I want to find the length of XY, XY will equal 1/2 of 16.8 plus 8.4. And then I'm just using my calculator. So 1/2 of 25.2 is 12.6.